Welcome everyone. My name is Tristan Harris and Ryan Moffat is on as well to help run the meeting. The topic today is setting up test sequences in WATTNet. We have a large group, so please remain muted. I will hold a Q&A at the end of the presentation, at which time I will read questions from chat and call on people who indicate that they have a question. With that, let's get started. So a quick overview. We are going to look into where the test sequence editor is, how we can select predefined test sequences to view, how we can edit those test sequences, and explore all the different testing parameters. Once we've covered all this, we're going to look into how you can create your own custom test sequences that will fulfill the requirements that you need to. So now here is the WATTNet software. Today I'm using WATTNet Express. Everything that I'm going to be showing today is compatible with WATTNet Basic, WATTNet Express, WATTNet Limited, WATTNet Basic. So first we will go into the admin panel here on the left-hand side. And then under the WinBoard tab is WinBoard Administration. And then under Setup, we're going into Edit Meter Test Sequences. And now this is where we are able to edit our meter test sequences. Begin right here is a drop-down for test sequence. This is where we can view all the different test sequences that we have created or that we have already predefined that were loaded in with the software. By clicking on it, we can see all of our tests that we have available to us. For now, we're going to go ahead and stick with default. Okay. Below here, we have multiple different parameters that we can go ahead and edit. First, we're going to begin with this one, which is step number. This indicates what step this test will be ran within the sequence. The next column is element. This defines what element we'll be testing. So if I click this drop down, we can see that we have series, which is A, B, and C elements, A element, B element, and Z element. So if I go ahead and change all these individually, and then we can see now we have a test that will run a test on each element. And then if I wanted to change all these to the same parameter, I could click on the name up here, and this goes for all these columns that we are going to cover. By clicking on it, I'm able to make one selection that will change everything in that column to our selection here. For example, if I want to make this entire column a series test, I can click on S, click OK, and we can see that everything under element changed to series. Next, we have the test column. Once again, if we click on the drop-down, we can see that we have full load, light load, power factor, creep, which will apply only voltage to the meter. This is really good if you need some kind of pause or some kind of stop while you're testing your meter. Jog, which will apply current and voltage to your meter. Demand, which will allow you to test demand registers within your meter. And then you also have options for relay, as well as sag and swell options. Moving forward, we have test voltage percentage. This is what percentage of the voltage you enter into the meter testing window it will test. Meaning right now, it's not going to test 100 volts unless that's the voltage that you enter in. So right now, if you were to put in 240 volts in the meter test window, this will test 100% of that 240 volts. If this value was 50% and you entered in 240 volts, then it would be testing at 120 volts. Next, we have test current percentage, which operates the same way as the test voltage percentage. Rather than this being the actual value for the current that you're testing, this is what percentage of the current that you'll be testing at. Next, we have phase angle. This is the angle at which your current waveform will be at. Next, we have test pulses and test duration. These two are going to define how long your meter test is. For a given meter test, you can either test in pulses or you can test by time. So if you want to test by pulses, this is where you're going to control that. If you want to control by time, then this is where you're going to edit the length of it. Right now, test pulses is going to measure kind of like the revolutions within a meter of the internal disk on mechanical meters. And then also goes for solid state meters that don't have the actual physical disk inside of it. Test duration, this is the seconds, minutes, and hours. So right now for test duration, each of these are going to run for 10 seconds. Moving on, we have service. This is going to control what kind of service that we're testing. So we click on this drop-down, we're able to see that we can test a one-phase service. We can do a three-phase Y configuration or delta configuration. Next is energy mode. This is going to control the metrics that's being tested. So if we click on this, we can see that we have a wide variety of metrics that you can choose from. Some of them being watt hour, bar hours, Q hours, volt hours, amp hours, delta var hours. So you can select your metric that you want to measure here. And then you can either apply that one step at a time or once again by clicking up here at the top, just like for all of these choices, you can change them all at the same time. Next is optics. This is where you can define what optics port you're using. So if you're using a mechanical meter, you can choose your disk. If you're using middle IR, upper or lower IR, you can select that here, as well as if you're doing a KYZ test. Next is the KYZ, case V. Right now we can see that it's grayed out, and this is because our optics isn't set up to test a KYZ. So if we go ahead and click on our optic and we select some kind of KYZ testing configuration, we can see that this is now ungrayed and that we are able to enter a value in there. Next, we have reverse power. Right now with this unchecked, this is going to be measuring delivered power. If we want to measure what the received power is for the meter, then we can check mark this, and then we will be measuring reverse power for power received rather than power delivered. Next is frequency. This is what frequency you're testing your meter at. And then moving over to the right, we have ISS duration and ISS magnitude. ISS stands for interrupt, sag, swell. So right now we can see that these are grayed out, and this is because our test isn't set up to do a sag or a swell test or an interrupt. So what these will do is they will either, for example, a sag will sag what voltage and current are being tested for either a moment, temporarily, however long you set it here, and by whatever percentage that you choose to. Swell will increase them for however long you define here, by whatever magnitude you select here. So if we come on over to test and click on the drop-down, we can go down and let's say we want to do an instantaneous sag. Now we can see we're able to enter in values for our cycles and our percentage. And down here at the very bottom of the screen, highlighted in blue, we're able to see what our range is. So for an instantaneous sag, we can see that we can do anywhere from half a cycle up to 30 cycles. For the magnitude, we can do anywhere from 10% up to 90%. If we change this to an instantaneous swell, we can see that our duration can be anywhere from half cycle to 30 cycles, and our magnitude is now 110% up to 180%. Moving forward, we have our upper and lower limits. These will control what accuracies come up as passed and which ones come up as failed. So right now, anything that lands between an accuracy of 99.800% and 100.200% will come up as a pass test. Anything that's above the 100.200 or below 99.800 is going to come up as a fail point. Next is desired accuracy. This is the accuracy that you're shooting for. Next is harmonic configuration. This is where if you are looking to test with harmonic distorted waveforms, you can select that here. If we click on this dropdown, we can see that we are supplied with some ANSI waveforms as well as some NRC waveforms. For example, if I choose NRC WF2/3, now rather than testing this meter with a default sine wave, we'll be testing with a sine wave that has harmonic distortion to it. Now, if I had went in and edited this waveform and made a revision of it, I can select what harmonic revision I want here. So by clicking on the one associated with it, you can see this window comes up where now I can select the revision. And once I have the revision I want, I can say OK, and it will use that revision of this waveform. Lastly, we have command. This is where you can go in and browse for an executable file that will then be executed during the meter test on this step. These executable files are created by the user, and they can do anything from switching the meter into test mode to activating a group of batch files for the user. Now moving up to the top, we have the back button. This button takes you back to the previous screen. Add. This will add a new test sequence. Delete. This will delete the current test sequence that we have up. Save. This will save any changes that we've made down here into our test sequence currently selected. We have print. This gives you the option to print to a screenshot or print the screen to an image, such as a PNG. And then we also have our import and export options. These are very handy tools for if you have test sequences on one station that you would then like to take to another station. So for example, if I have, let's say, 5 different test sequences here, they're really good, they're doing exactly what we need them to do, but another test station doesn't have these. Rather than taking the time to manually create each one, I can click on export and export each test sequence individually to a USB or a thumb drive. And then I can take that USB over to the other station, plug it in, and then select import and select those test sequences to have them available on that test station as well. Over here, we have the help button. By clicking on it, we're able to kind of see a variety of topics. And as you click into them, they're going to provide you different steps on how to operate it and how they work. So this is a potential tool for helping you with some questions that you may have. Right-hand side, we have the Save As button. This will save the current test sequence under a different name. We have Add Step, which will add a new step to the very last row. We have Delete Step, which will delete the selected step. Then we have Insert Step, which will insert a new step below the one that's currently selected. So now that we know all of our tools, let's talk a little bit more about creating a custom test sequence. So to begin, we can go up here and click Add. And we will be prompted with a window to name the test sequence. So let's say we want to create this test solely for a 2S meter. We can name it 2S meter. Click OK. Now, this is asking me if I want to save the changes I made to the default test sequence, and I'm going to say no. All right, so now we have our test sequence up here for a 2S meter, and we have one step. Now, let's say for this 2S meter, we need to measure delivered power as well as received power under a full load test and a power factor test. To do this, we can go ahead and add our second step. And as I do this, it's going to, as I add steps, they are going to clone the previous line and bring it down one. So we can see that this right now is also as a full load test. When I click on this to change it to power factor, we will also see the phase angle change, which I will demonstrate now. We can see that I changed to 60. We did this kind of as a default to help streamline setting these tests up. Makes it a little bit easier for the user. So next, we can go ahead and we see that we have our full load step, our power factor test, our power factor step. And we can add another step. Make it full load. And since these two are measuring delivered power, we're going to make this one measure received power by check marking this box over here under reverse power. Then we will add our last step for power factor. And once again, since this step clones the previous one, our reverse power is already selected. So now from here, we can go ahead and do save. And now this saves everything that we've done to the test sequence to Estimator. If I change the test sequence back to default, we can see that we still have our default test sequence that we first looked at. And when I go back to Estimator, you can see now we have the one that we just created. Now let's say that we also need a test sequence for a Estimator that only measures received power. What we can do from here is, since we do not need these two steps because they are measuring delivered power, we can come over here, make sure the first step is highlighted, and click delete. And now that test step is deleted. And now since our new one that's testing power factor also isn't measuring delivered power, we can go ahead and click delete. And now we have a test sequence for a Estimator that measures a full load test and a power factor test on received power. So rather than saving this over our Estimator test sequence that has delivered and received, we can click Save As. And now it's going to save this test sequence here as a brand new one. So we can go ahead and say Estimator. And now if we go up here, we can see that it now has a new name, Estimator received. And click on the drop-down, we have Estimator. When it's selected, see that we got our previous step back. So now if we no longer have a need for Estimator received, we can select it. Come up here to the delete button, select it, and it will ask us if we are sure we want to delete this test sequence. If we click yes, it will go ahead and delete this test sequence. And then if we needed it again, we would have to remake it. By clicking yes, we can now see, clicking on the drop-down for the test sequence, we no longer have Estimator delivered. Due to the COVID pandemic, this year's WeMeet has been rescheduled for September 15th, 16th, and 17th. The event will be held at our Lafayette, Indiana facility. If you're unfamiliar with what WeMeet is a premier user event where Radian customers can gain product and application knowledge. You're able to see the latest hardware and software advances, receive invaluable hands-on training, as well as directly engage with the Radian community of support staff, sales representatives, and customers. If you're interested in registering for WeMeet, you can register today at radianresearch.com. At this time, I'd like to begin taking questions. To avoid talking over one another, please use the chat feature to pose your question or ask to be called on. I will read questions submitted in chat or call on you to ask your question out loud. All right, we have a question from Terry. What is a standard number of pulses to test? So this kind of depends on your requirements. Test will run at 1 pulse per step, but you can change that to whatever you need it to be. Another question. If the time to test, the number of pulses that we've set is different than the test duration, what happens? For a little bit of clarification, are you saying if your amount of time it takes to, let's say, test 2 pulses isn't the same time that you set as your test duration, what would happen?
Yeah, exactly. That is what I meant. If the time it takes to test the pulses is different than the test duration, then what happens? There are 2 settings. One is the number of pulses, and the other one is the setting of the test duration.
Okay. So when you go into test your meter, you have the option under options to test either using pulses or using a set time. So if the amount of time that it takes to test the number of pulses is longer than the test duration you have set, that won't conflict with each other, because you can either test by pulses or test by time, not both at the same time.
In that case, if we want to test on the basis of number of pulses, then what do we set at the test duration? Is it going to be 0 or something else, or what? Or is it going to be the actual time it takes for those pulses to be tested?
If you're looking to do pulse-only testing, then you don't have to worry about what the test duration time is set to.
So that can be left at whatever setting it was?
Correct.
Okay.
When you select to test by pulses, it will solely look at the pulses column for how long it needs to run the test. It will not look at the test duration time unless if you set to test by time.
All right, thank you.
Where would we be able to get help/documentation with how to do commands such as putting a meter into test mode? Ryan, would you mind taking this one?
So let me see that question one more time here in the middle of it. Connor, what I'm thinking on that one is it depends on 2 things. 1, what meter type and manufacturer you're using, and 2, how you plan on interfacing with it. Our software has the ability to create a virtual COM port on the PC to allow an optic coupler that's attached to the test board to be used to program meters. But typically putting your meter in test mode or communications through the meter is really going to be done through that manufacturer's software. So you can use the test board to energize the meter, get it powered up, and then use the built-in optic coupler on the test board to then connect up to the meter and communicate through it that way. But in terms of how to do that, that's probably where I would look at talking with your specific meter manufacturer that you're using and their software on how to talk to the meter and program it that way.
Once a script sequence has run, can the results be exported to a spreadsheet? Ryan, would you mind taking this one?
So when you run a meter test in WATTNet, Basic or Express, Limited and Plus, all of the results for that test are going to be saved inside of WATTNet's SQL server that's tied to. WATTNet has the ability to export that data out to a CSV file and get that into a spreadsheet format for you if you desire.
All of our meters are programmed to measure received energy along with delivered. Should we be testing the meters for reverse energy as well? So if you're measuring received energy, you're also measuring for reverse energy. Reverse energy is another way of saying received energy.
And then real quick to add on to that as well, I would say for that specific situation, I think it depends on where that meter is going and what you plan on doing with said meter. If all of the meters are programmed to do delivered and received, and all of the meters are going to be going into, let's say, a solar installation or customer as a generator of some sort, something that's going to pump energy back onto the grid, if the situation calls for delivered and received power to both be measured at that site, it might be beneficial for you to test both delivered and received to make sure that the customer is being accurately credited for the power they bring back, and you're also measuring the delivered power that you guys are providing to the customer and getting billed accurately that way too. So I think it depends on the site there specifically. So if the meter is going into a service with delivered and received, it might benefit you to test both delivered and received. But if you have a program delivered and received that's just going into a typical site where no received power would be there, the delivered testing should cover 100% of what that meter plans to do.
Is there a user guide or manual reference document available for the setting up of test sequences that was just provided? Ryan, do you know if we have a user manual available for setting up test sequences?
The WATTNet basic user manual and some documentation that we have inside the user manual that should cover setting up test sequences as well if you want a hard copy. Alongside that, if you have any questions or anything while you're setting up a test sequence, or if you want to see something very specific, Tristan will give you the email for us at the end of this presentation. Please feel free to email us or give us a call with any specific questions that you have if the manual or guide does not specifically address something that you're looking at.
Is there an industry standard as far as the accuracy test for plus and minus percentage? This typically depends on utility or whoever is doing the test. There's usually some kind of percentage provided by the plant that you would want to test between. So this kind of depends on your location as well as where you're testing. Can WATTNet be controlled by external software? Example, have WATTNet pause while a meter registers are being read and or reset. Ryan, do you mind taking this one?
Not particularly. The best way to do that would be some form of batch file scripting. But even with that, usually it's going to be a manual process of controlling the load to the meter through the software. And then when you're done reading registers, resetting registers, go ahead and moving on with the test. Typically what I would recommend if you're wanting to do some steps in between you have the ability to put what we call a creep step inside of your test scripted in. If you're doing stuff before or after the test, you can put a creep step, which will then say, all right, I'm going to just apply voltage to the meter, no load, just power it on, so you can then talk to it, run through your test, and then have at the end of the test another creep step. So once it's done, it pauses, keeps the meter lit up, so you can then read registers, reset them if they're going back out to the field, or if you're doing these for acceptance testing, things like that, and bring them back in. So I would typically recommend if you're looking for something semi-automated, I would put in creep steps at the beginning or the end or both to assist with meter programming.
Can we sync these test sequences to our RW30? Yes, you are able to sync these test sequences with your RW30, but you will want to make sure that your data view mapping matches. All right, let's wait about 15 seconds for any additional questions. All right, thank you all for attending. If you think of any questions, email technical support at technicalsupport@radianresearch.com or call 765-449-5576. You can also visit our website at radianresearch.com. We enjoy being your solutions partner and look forward to working with you. I hope you have a great day, and we hope to see you at the next presentation. Thank you.